Welcome to the Explainer. You know that honeymoon phase when you first start using AI to write code? It literally feels like magic. But then, boom, that raw, unchecked code completely breaks your application in production. Well, today, we are fixing that. We're going to transform raw Salesforce CodeGen oblets into reliable, fully sandboxed, production-ready Python functions. Think about it like this. The old way, just basic inference, is essentially a slot machine. You pull the lever with a natural language prompt, and you get raw, unconstrained code back. You might hit the jackpot, or you might just get a bunch of syntax errors. We are building something way better, a digital assembly line. Every single piece of generated code is going to be isolated, evaluated, and organized before it ever even touches your code base. Because, let's be real, generating code is easy. Generating code you can actually trust. That is the real bottleneck in AI engineering right now. So how do we build a framework that automatically validates and secures these model outputs before deployment? Here is our game plan for today. We're going to start by moving beyond basic generation, then load up the CodeGen model, build in some serious validation and safety, benchmark our tasks, re-rank the best of N candidates, and finally dive into multi-turn program synthesis. Let's get to it. All right, kicking things off with part 1, beyond basic code generation. We absolutely have to stop treating Salesforce CodeGen like just some fancy autocomplete that spits out formatted markdown. Instead, we're going to wrap it in a highly structured code generation engine. This engine parses the output, autonomously extracts the actual code blocks from all that conversational fluff, filters out the hallucinations, and then organizes the winning solutions. We are literally turning a conversational AI into a strict programmatic utility. Moving right along to part 2, loading the CodeGen model. Getting our environment ready requires a few strict checks. First up, verify that GPU availability. Running LLM inference on a CPU from automated pipeline, that's going to massively bottleneck your entire system. Once we've got the GPU confirmed, we select our specific CodeGen model weights and securely pull both the model and its tokenizer directly from Hugging Face into our local memory. We need that low latency access. And before any actual generation begins, we've got to lay down some architectural groundwork by establishing modular helper functions right now, specifically for things like text generation and formatting the display output. We prevent all that boring boilerplate code from polluting our logic later on. We want the core pipeline to remain incredibly clean and strictly focused on validation. Next up is part 3, building validation and safety. This is where we build our utility layer, which is basically a rigorous gauntlet for our generated code. We extract the function, but hey, we do not trust it right out of the gate. We run syntax checks using the abstract syntax tree to catch any malformed logic. We apply static safety checks to block malicious imports. We execute the code in a restricted, sandboxed environment with super strict timeout handling because an AI-generated infinite loop taking down your server is a bad day. And finally, we run actual proper unit tests. And standing right at the end of this gauntlet is our scoring function. Because just passing unit tests, that's not enough anymore. The code has to be optimal. This algorithm calculates the cyclomatic complexity of the script and ranks it. It actively penalizes overly complex, convoluted logic. We are demanding code that is not only safe and correct, but elegantly simple. All right, diving into part 4, benchmarking generation tasks. Let's ground this pipeline with a quick baseline test. We toss it a natural language prompt, asking for a simple circle area function. The model generates the raw text, and our utility layer instantly takes over. It extracts the Python block, parses the syntax, and returns a concrete pass/fail state. This just proves that the fundamental plumbing of our framework is solid. But we aren't going to stop at basic middle school geometry. We define a comprehensive suite of distinct programming tasks to act as our automated stress test. By throwing algorithmic challenges, data parsing, and string manipulation at CodeGen, we map out exactly where the model excels and, more importantly, where its logic completely breaks down. Which brings us to part 5, re-ranking best of N candidates. This right here is the absolute secret weapon of the framework. Best of N generation. We crank up the model's temperature and generate a massive volume of candidate solutions. That's our N, for a single prompt. Remember, AI is inherently probabilistic. By generating, say, 20 different approaches to the exact same problem, we drastically increase the mathematical probability that at least one of them is going to be flawless. So our pipeline takes all those N candidates and runs them through the unit tests, the syntax parsers, and the complexity scorers, and it aggregates all that telemetry into a structured data frame. Then it automatically re-ranks the survivors, The final output isn't just a lucky guess. It is a statistically proven winner, like candidate 4 here, identified as the absolute safest and most efficient solution. Finally, we reach part 6, multi-turn program synthesis. This is the big leagues. This is where we move from just writing quick scripts to actually building software. Instead of prompting the AI to write one massive, fragile application all at once, we chain smaller, validated functions together. We generate a word normalization module, pass that output to a word counting module, and feed that into a selection module. We are composing independently verified blocks into a highly resilient workflow. And because the pipeline is so strictly structured, your prompting strategy becomes incredibly versatile. You can feed it docstrings to generate functions from scratch, give it half-written logic for partial completion, ask it to strictly generate unit tests for your existing software, or even just dump some nasty legacy code in and ask for a complete refactor. The pipeline handles the validation regardless of the input method. To wrap things up, the workflow aggregates all of this telemetry, which lets you visualize candidate pass rates and keep an eye out for model degradation. But most importantly, it exports those surviving, validated Python functions as reusable artifacts directly into your environment. You are left with a completely reliable, interactive utility that is ready to tackle custom tasks on demand. Our source material puts it perfectly, noting that we've built a complete mini framework for experimenting with CodeGen, comparing generated candidates, validating their correctness, and exporting useful results. Think about that. We didn't just write a one-off script today, we engineered a full end-to-end framework. We transitioned from relying on unpredictable, raw model outputs to owning a deterministic, reliable system. The era of the AI slot machine is officially over. You now have the blueprint for a digital assembly line that enforces structure, safety, and scale. The question isn't whether AI can write code anymore, it's whether your infrastructure is actually ready to validate it. So, what critical systems are you going to build with your AI pipeline today? Thanks for tuning in to this explainer.